For this video, we are going to be discussing solving quadratic equations by factoring. So we've already discussed how to solve a quadratic equation by graphing it, and now we're going to be looking at another method that would work. So in our unit on polynomials, we discussed how to factor a polynomial. And the reason we did that is because some quadratic equations can be solved by factoring, and we need to know how to factor something in order to do that. Now, not all quadratics can be factored. If you remember back to polynomials, not every polynomial can be factored. So, quadratics that cannot be factored are called prime, similarly to how polynomials that can't be factored are called prime. So if we think about what this is going to look like, if I was to say give you this polynomial, x plus 2 times x minus 2. Okay, so this is a polynomial that's been factored into two binomials. Now all I have to do to make this a quadratic equation is stick equals 0 at the end. If we have this, we know that either this term, we have these two terms being multiplied together, x plus 2 times x minus 2. So I know that either x plus 2 equals 0, or x minus 2 equals 0, or they both equal 0, because if I multiply them together, I get 0. So, if I think about these, if x plus 2 equals 0, then x equals negative 1. And if x minus 2 equals 0, I'm sorry, x doesn't equal negative 1, x equals negative 2. If x minus 2 equals 0, then x equals positive 2. And these are our two solutions. If I was to graph this quadratic, I'd have one solution at negative 2, one solution at positive 2, and my quadratic would look something like this. So, for these problems that we're going to do, the way we find our solution is simply by factoring them and setting each one of our factors to 0 and solving for x. So let's take a look at the procedure for doing this. So the procedure is, we have to first put the quadratic into the form ax squared plus bx plus c equals 0. This is the same as graphing. You're going to see we're going to do this pretty much every time we solve a quadratic. Then we're going to factor the polynomial on each side. We're going to set each factor to 0, and then we're going to solve for x in each factor. So let's take a look at some examples. Here is example number 1. So solve by factoring. I've got x squared plus 5x equals 6. So my first step to be able to do this is I need to put this in the form ax squared plus bx plus c equals 0. In this case, it's not there yet because I have this 6 over on the side, so easy way to get around that is just to subtract 6 on both sides. And I end up with x squared plus 5x minus 6 equals 0. So now I'm just going to follow the procedure for factoring. I know my first step, I need to see if there's a greatest common factor to pull out of these. There is not. So now I need to figure out how am I going to split 5x into two different terms so I can group. So to do that, I'm going to make my little square. I know this is 1x squared, so I do 1 times negative 6 to get negative 6 up here. And then down here goes 5. I need to think of two terms that add to 5 and multiply to negative 6. They are 6 and negative 1. So this becomes x squared plus 6x minus x minus 6. Next step to factor is I need to group the first two terms and the last two terms. Now I need to factor out my greatest common factor of each of these. Greatest common factor of x squared and 6x is x. I'm left with x plus 6 inside. Greatest common factor of negative x and negative 6 is negative 1. Factor that out, I've got x plus 6 left inside here. I know I'm doing this right because these two are the same. Now I rearrange my factors. X plus 6 goes into one set of parentheses. The outside, x minus 1, goes in the other. So nothing new so far. We just factored. Our next step is that for this to equal 0, either x minus 1 equals 0, or x plus 6 equals 0, or they both do. So now I'm going to set both my factors, x minus 1 and x plus 6, equal to 0, and solve. Add 1 here, subtract 6 here. I get x equals 1 and x equals negative 6. Now, let's go ahead and check these. The way we can check them is pretty simple. All we have to do is plug each one of these into my original expression here. So let's see what happens. If I plug 1 in for x, 1 squared plus 5 times 1 equals 6. 1 squared is 1. 5 times 1 is 5. 1 plus 5 equals 6. Well, that answer checks out, so that's good. Plug in 6, or plug in negative 6. Negative 6 squared plus 5 times negative 6. Negative 6 squared is 36. 5 times negative 6 is negative 30. 36 minus 30 is 6. So both of these check out. My answers are 1 and negative 6. Now another thing I can do to check this is if I graph these. So I'm going to bring up my graphing calculator here. And I'm going to graph this quadratic equation right here. Delete this. I'm going to graph my quadratic x squared plus 5x minus 6. All right, so you can see my quadratic here. And I'm going to tell it to find the roots for me. It finds one root is at negative 6. And it tells me the other root is at 1. So checking my work, I can see that I did this right. So that is good. Let's move on to example 2. So now I want to solve by factoring. Once again, I've got 4x squared plus 9 minus 12x. First step is to take that, add 12x on both sides. So I get 4x squared plus 12x plus 9 equals 0. Always have to have one side equal to 0 to make this work. All right. Check for greatest common factor. There is not one. I'm going to make my square. 4 times 9 is 36. Down here I've got 12. Two numbers that multiply to 36 and add to 12 would be 6 and 6. So now split this 12x into 6x plus 6x. Group. Oh, that got weird. Try that one more time. Group the first two terms and the last two terms. Let's see what we've got here. 4x squared and 6x share a 2x, left with 2x plus 3 inside. 6x and 9 share a 3, left with 2x plus 3 inside. Rearrange them into 2x plus 3 times 2x plus 3. Now notice these are both the same, so I can rewrite this as 2x plus 3 squared. Now from here you can see there's only one factor, meaning there's only going to be one answer, one solution. So if we take a look at this, 2x plus 3 equals 0. Subtract 3 on both sides, I get 2x equals negative 3. Divide by 2, I get x equals negative 3 halves. So let's check our work. We're going to check it two ways. First, plug negative 3 halves into the formula. Into our original equation. Now, let's see. Negative 3 halves squared. That gives me 9 over 4. And 9 over 4 times 4 is 9. Negative 12 times negative 3 halves. Negative 12 times negative 3 is 36. Divided by 2 is 18. I have 9 plus 9 equals 18. 9 plus 9 is 18, so my answer works. The answer is negative 3 over 2. Let's go ahead and grab the graphing calculator and see how that looks. Clear this guy out of here. So if I put into the graphing calculator 4x squared plus 12x plus 9, graph it, we see that it touches the graph at exactly 1 point, which confirms for me that it does only have one solution. Check the roots, and we see that negative 1.5, which is negative 3 over 2, is the solution, so we did it correctly. Oh, computers decide to go a little crazy on me. All right, let's move on to example 3. Wow, maybe. My computer will chill out. Well, example 3 is looking a little weird. And by weird, I mean I gave the answer away, so let's... Okay, now, let's take a look at example 3. So, I've got x squared equals 4x. So I know that I need to put this into ax squared plus bx plus c equals 0. So the way I'm going to do that, subtract 4x on both sides. Now in this case, okay, ax squared plus bx plus c equals 0. Some of you might be noticing I don't really have a c term here. Well, if we think about that, I do have a c term. It's just 0, but I don't really have to worry about that. So my next step is to see, okay, is there a greatest common factor on these two? There is. It's x. So I factor that x out. X squared divided by x is x. 4x divided by x is 4. Now what I notice is x minus 4, there's nothing to factor there. That's all by itself. So I actually have two factors here. I have x and I have x minus 4. So what am I going to do now? Well, now I'm going to set them both equal to 0. Okay? If I set x equal to 0, I just get x equals 0. If I set x minus 4 equal to 0, I get x equals 4. So now I've got my two solutions here. X equals 0, x equals 4. Let's go ahead and see what we get when we plug them in. I'm going to plug them into this original equation. Plug in 0 first. 0 squared equals 4 times 0. 0 squared is 0. 4 times 0 is 0. So that one checks out. Good. 0 works. All right. Now let's try 4. 4 squared equals 4 times 4. Well, 4 squared is 16. 4 times 4 is 16. So that one checks out. All right. So I know that my answers are 0 and 4. Okay. Let's head over to the graphing calculator and make sure it works on there. Just kind of triple check our work. So I'm going to put in x squared minus 4x. We'll graph that. Notice I have two solutions. It looks like 0 and 4. Let's be sure, check our roots. Well, there's one, x equals 0, and the other one, x equals 4. So you can see that those are the correct answers. So now you see how to do this. Just put the equation in the form ax squared plus bx plus c equals 0. Factor the polynomials. Factor the polynomial. Set each factor equal to 0, and solve for x. So your try it problem for tonight is to solve by factoring 3x squared minus 11x equals -6.